Discuss Fourier series representation of discrete time periodic signals. We know for x of n to be this periodic the x n plus n for all n. This must satisfy the equation to be this signal xn to be periodic. Xn equals x n plus n. And then what is the period of this function signal? Period of the signal. The period of the signal can be found by making this circle. From here to here it will take 2 pi radian. Then the fundamental period is the smallest positive integer n for which this condition holds, that is omega naught equals 2 pi by n is the fundamental frequency. Now we are going to find the set of discrete time complex exponential signals that are periodic with same period n is given by now we make new notation phi k of n equals e j omega naught k n, where k value from 0 plus minus 1 plus minus 2 to this, and this let's reduce this j, and the k is same, and the omega naught which we have discussed previously is 2 pi by n. 2 pi by n. And also we know in for discrete time periodic signals there can be only n distinct signals in the set of given above equation, which is phi of n, phi of 1, and reduced to, if this is 0, then for period n minus 1 up to this much, where we can rewrite this as phi k n equals phi k plus r n, this much. The new now we want to represent any general periodic signal, signals x n in terms of linear combination of signal set of phi k n. So the x of n equals summation k a k e, this is phi k n n, and we know this k value is for period n, and this can be started from anywhere. If this is the n, and if we take this n, we can take this n from infinity to infinity, just the n, this angle bracket. Okay, it can be rearranged now. Phi a k, and we know this phi k as e k 2 pi by n. Yes, where k range has range over 0 to n minus 1. After this, if it will again repeat the same thing as I have said in previous slide. Therefore x of n equals, therefore the x of n equals k n a k e j k 2 pi by n, and this can be, we rewrite this series as the finite series, so that so for discrete time Fourier series, the problem of convergence will not appear. If the signal is periodic in discrete time, then we can say that it will always converge. Okay. Now our interest is to find this AK. Our interest is to find AK, and we are going to find AK. Now we are going to find AK. We have x of n equals summation k, the angle for any value of n. The period n, it can be started from anywhere, and to the values can be n. Yes, e j k omega naught n. Then we multiply both sides by e j r omega naught n equals this, the same thing, just e j r omega naught n. Taking the summation over n times n terms, thus it will be for n x of n e j r omega naught n equals n k n ak and we know this item is equals to n for k equal to r and 0 for or k not equal to r. So our equation reduces to n f of n minus j minus n equals to n times ar. This n times ar. Then we finally found the ar 1 by n tends to this x of n minus e j r omega n, and this r can be replaced by k. Therefore ak equals 1 by n x of n e j k omega naught n. Now we want to see again, for discrete time Fourier series DTF. Yes, the action is k tends to n, ak e j k n, and ak is 1 by n tends to x n e minus k minus n. We know this x of n is k ak and phi k of n, which I have written here. The action can be, we want to represent any general periodic signal action in terms of linear combination of signal set of phi k n, so that for k equals 0 to, what will be this term? For periodic signal in discrete time, for periodic signal, yes, for periodic signal, if this is the case for 1 0 1 2 3 4, if period is n equals 4, for period 5 this will be the same value. Yes, again it will be repeated for period. So this n minus 1 can be represented as xn as a naught phi naught n, a1 phi naught 1, and similarly to a n minus 1 phi n minus 1 n. Equation A. For if k equals 1 to, what will be the period? Period is n. If 0 from started from 0 to n minus 1, and again if you continue, the same thing will be repeated. Yes, for if I have written an phi n, then this term will be the same, exact same. Then f of n equals a1, this is 1, phi 1 n, a2 phi of 2 n plus a n phi of n, and this term is b. And we know these things are the same thing. The difference is only on this and this. But we know this phi of n is equals to phi n, the capital N. So a naught is equals to an. Thus we have obtained this, and if a is k, then a k plus n. Therefore a minus 1 equals a minus 1 plus n, or a minus 2 equals a minus 2 plus n. The spectrum, the line spectrum will be in periodic nature, which is not in the case of CTF. Yes. It is also it 1 plus a 1 plus n, and this case is only on discrete time signals. Therefore, CTFS AK are not periodic, whereas DTFS AK are always periodic.